Let's talk about the quotient rule. Had some technical difficulties up here. Sorry about that. So just like the product rule was not just the derivative of one times the derivative of the other, there was two different parts. The quotient rule is very similar. The derivative of something divided by something is not the derivative of the one divided by the derivative of the other. The quotient rule is different. And so if you ever have the quotient of two things, division, and we want this derivative, first of all, it's a big fraction. So what we do is we take g times f prime minus f times g prime, all divided by g squared. The way I remember this is I think about top and I think about bottom. So it's bottom times derivative of top minus top times derivative of bottom all over bottom squared. G f prime minus f g prime over g of x squared. Now you might recognize these things here. These two terms, g f prime and f g prime, those are in the product rule. But in the product rule, it's addition, so the order doesn't really matter. Whereas this is subtraction, so the order definitely does matter. Let's say you memorize this wrong and do the wrong order. All your rates of change would be opposite. Like if you expected a rate of change of 4, you'd get negative 4. Or if you expected a rate of change of negative 12, you'd get 12. You might think, well, that's no big deal. Well, that's a huge deal. Is it important to be driving toward something or away from something? That'd be the same. That's to be the difference between positive velocity and negative velocity. You might tell your boss, hey, no, our profits are increasing, when in fact they're negative decreasing. That'd be a problem. So make sure you get this order memorized correctly. It is subtraction, bottom derivative top minus top derivative bottom over bottom squared. All right, let's look at a couple examples then. We'll do kind of like we did with the product rule. Let's say this is our function. So we have some function h, x plus 3 over x squared minus 3. Find h prime, and then write the equation of the line tangent to h at x equals 2. Alright, so to find h prime, here's the quotient of two things. So I'm going to say this is f and this is g, top, bottom. So I need to take the bottom, and I'm going to write it out, the derivative of the top minus top times derivative of bottom all over the bottom squared. Okay, so let's clean this up. This would be x squared minus 3 times, well, the derivative of x plus 3 is just 1, minus x plus 3 times the derivative of x squared minus 3 is 2x all over x squared minus 3 squared. And since these are pretty simple, let's go ahead and clean this up. This would be x squared, x squared minus 3. And this would be minus, this would be 2x squared plus 6x. So that's going to be minus x squared minus 6x minus 3, right? 1 minus 2 is negative 1, negative 6x minus 3 all over x squared minus 3 squared. So that would be the derivative. That would be the instantaneous rate of change of this function h at any x. So now the next part, write the equation of the line tangent at 2. Alright, what do I need to write the equation of the line? I need a point. I need a slope. Well, here's an equation for the slopes everywhere. I just want the slope at 2. And the point, well, that's just an x and a y. Well, I know x. Let's do that first. So I need to find out what is h of 2. Well, that's going to be 2 plus 3 over 2 squared minus 3. Well, that's 5 and that's 1. So the point is 2 comma 5. Now I need to know the slope. Well, that's the derivative. at 2. So let's plug in 2 to the derivative. So that's going to be negative 2 squared minus 6 times 2 minus 3 all over 2 squared minus 3 squared. Well, 2 squared minus 3 is 1. 1 squared is 1, so this bunch is 1. Negative 4 minus 12 minus 3, that's a whole bunch of negative 19. Well, then that's the slope. Well, now I have a point and I have a slope, so I can use the point slope formula. Y minus 5 equals mx minus 2. And that is the answer, but let's go ahead and clean this up. Let's get rid of these parentheses. That'd be negative 19x plus 38. Add 5 to both sides, so y equals negative 19x plus 43. Okay, let's do another example. Let's take this function here. So we have find the derivative of 4x minus 3 over the square root of x minus 2. Okay, well that's going to be bottom times, I'm going to write out, you don't have to do this eventually you'll just put times 4 because you'll do this derivative in your head, but I'm going to go ahead and write it out. So there's bottom times derivative top minus top times derivative bottom all over bottom squared. So here's bottom top minus top bottom over bottom squared. Okay, well this would be the square root of x minus 2 times 4 minus 4x minus 3 times, okay, again, don't see square roots here. See that as x to the 1/2. So its derivative would be 1/2 x to the negative 1/2. And the derivative of 2 is 0 all over the square root of x minus 2 squared. And that would be it. That would be the derivative of this function. Now, depending on the directions of your problem, you may or may not want to simplify this. But just take great care if you do simplify it. Okay. I'll post these notes and I'll send you a note announcement. If you ever go on YouTube and look for videos, there's a woman who makes videos that I follow. Her handle or whatever is MathBFF. If you go onto YouTube and look for MathBFF, and then in the little search thing, search for product rule on her videos. She does really nice videos. They're very easy to follow. There's tons of examples. So you could do that. Go on to Google, go to YouTube, just look for product rule examples, look for quotient rule examples. You can even do, in Google, do product rule file type PDF examples. You'll get a whole bunch of examples. Okay? All right, watch these videos. Check some other videos online, and I'll see you on Tuesday.